Alright, so when I put a negative 1 in, what do you guys get? Yeah, 1/3. Aw. God for this mark. For each of the 0, of course, is 1. So everything that looks like this is going to have a y-intercept of 0, 1. It's kind of nifty. Now remember, now watch, let me show you guys. If I put like +2, that would shift everything. So all that stuff we learned about shifting isn't just for parabolas, it's for every freaking function. And to be really honest, it doesn't even matter if it's a function. It could be something that does weird things and then I just pick the whole thing up. Can't like it. There are functions that give you like spirograph stuff. We're not going to worry about that. Yeah. Okay. So negative 1 gets me to 1/3. So I'm about 1/3. 0 goes to 1. And of course 1 goes to, that's great. And then here you just put this down there just to show, if you know what the hell's going on back there. Like at 2, it's already at, what would 3 squared be? 3 squared is 9. At 3, it's at 27. At 4, it's at 81. Holy shit, that's what they mean by exponential growth. All right. Throw a couple rabbits in a room with some food. A few days later, hello, family of rabbits. Not days, maybe. My rabbit biology needs some work. Okay, all right. Now, let's see if we can figure out. We can definitely do this. It doesn't even matter. This is a brand new freaky ass function. Graph the inverse. See if you guys get what to do with that asymptote. Let me make sure this helps out a lot. That asymptote is currently along the x-axis. Inverse is, what do I do with the x and the y? Flip them. So if it's currently on the x-axis, the inverse is going to be on the, yeah, isn't that crazy? So the asymptote is now here. This goes through negative 1, 1/3. So this function goes through what? 1/3, negative 1. So 1/3, negative 1. This one goes through 0, 1. So this other one goes through 1, 0. Okay, so this other one goes through 3, 1. So it's going to have this shape. Let me make this more, get out of there. It's a trap. I always think about it. The shield generator still on first? All right. And you see that still has that beautiful reflection around the y equals x. We're going to give this guy a name. All right, so the name that was given to this function. Sort of like, all right, if y equals x cubed, let me do it like this, sorry. If g of x is x cubed, what is g inverse? It gets its own symbol, right? What is g inverse then? What's the opposite of cubing? Cube root, right? If I had never made that symbol and I just had y as x cubed, and I said the inverse is x equals y cubed, that is unsatisfactory. It's even more than that. I don't know what I'm really doing to x to get y. I've just got it written in reverse, and I haven't tried to solve it because we didn't make a symbol up for it yet. But thank God we did make a symbol. Unfortunately, it's the wrong symbol, but I already talked about x fractions are better. Here, the opposite of this. Let's do the first step. The inverse would be represented by this. That is lacking. I want to be able to solve for y, and I want you guys to realize this is very fundamental. If I solve this for y, I already have to have a symbol for what it is I'm doing. So we have the cube root symbol to show me what the hell I'm doing to both sides right here, right? Take the cube root, I get there. So at this point, we are at the point where if we were alive several hundred years ago, we could have come up with a better symbol than what they did, but here's what they came up with. And the reason people don't, there's a couple reasons people don't like this. You guys were a little more used to roots because we've internalized what the root symbol is asking us. This one we haven't done that with yet. So here's what this looks like. Log base 3 of x. That's how you read that. Why is it base 3? Because it's base 3. So if I had 2 to the x, it would be log base 2 of x. So let me ask you this. If I say 27 equals 3 to the y, what question is that? What am I trying to answer? What is that saying, asking me?
What do you have to raise 3 to get 27?
Oh my God, it's almost like I fed you that. Sorry, Jen. Yeah. What do I have to raise 3 to get 27? Same way as if I had this question here. If I had x, let me see. Yeah. If I had 8 equals x cubed. I'm asking myself, what do I cube to get 8? And to get that, I would take a cube root. This is saying, what do I raise 3 to? What power do I put on 3 to make it become 27? And to do that, to represent that question, we use this crazy-ass symbol. So if you just get over the fact that it says freaking log, and there's all kinds of dumbass math jokes, and I'm not going to put you through them, about log cabs and all kinds of stupid shit. All right. We can't stop ourselves. All right. Oh, let me do this before I get into this stuff. I want to immediately let you guys. Does everybody have that sheet? Or in the back it says at the top exponents and logarithms. All right, the one side is the inverse stuff we did the other day. It would be amazing if you guys could stomach just working with somebody on this. If not, just try to read through this and do it. I know it's some reading. That's too bad. Everybody's got that sucker. Go ahead and do it. I'm tired. I'm going to let the paper teach you. Yes? You good? Okay. You got a question?
No.
No? Okay. I got you.